This problem is particularly suited in, by you and particularly interesting because here the concept of three dimension is involved and cross product could be used, but that is outside the scope of discussion for this screencast. What I'm more interested in knowing is how is this tangential velocity v related to angular velocity, that is omega. So I missed on writing omega, and that is just a Greek counterpart of w. So we can write angular velocity is represented by omega as opposed to angular position represented by theta. So what velocity means is change of theta with respect to time. And similarly, what angular acceleration means is change in omega with respect to time. So this angular acceleration means this. So let's start up with this. What happens to omega for one complete rotation? So one complete rotation means a change in angle that corresponds to 2 pi radians. So what happens when delta theta is considered for one revolution? So for one revolution, the delta theta becomes 2 pi because the total angle subtended for one complete rotation is 2 pi, and time becomes time period. So we know now that omega, so this can be 1 by time period is written as 2 pi f. So this is the conversion we need to remember, that if we multiply 2 pi to the frequency, we get angular frequency, and that is the same as angular velocity. And you don't need to confuse yourself with this because angular frequency is the same as angular velocity, because that is how we defined circular motion, that a particle is completing one lap or one complete circle. So you don't need to confuse yourself with these two terms, and that is why I'm writing it here to specifically emphasize that in terms of circular motion, angular frequency and angular velocity means the same thing. Okay, how is this angular frequency or angular velocity related to linear velocity with which the object is always moving and falling to and in a circular path, always following a circular path? But wherever the object is irrespective of the position, angular position of the object, the object will always have the same tangential velocity v. Can you state a reason for it? Because the rate of rotation is the same, so it cannot have more speed at any instant. The magnitude of velocity will always remain the same. Why is the direction not remaining the same? Because direction is always following a 90-degree angle with radial vector. So direction is changing, but the magnitude of the velocity vector is not changing, and that is why we can define uh, velocity for one complete rotation for this vector as v is equal to what, distance upon time. So for one complete rotation, the time will become capital T, that is time period of rotation, divided by, that is 2 pi r in the numerator, divided by time period. 2 pi r is the perimeter of a circle, that is the distance covered in one complete rotation. So one cycle. So from here we can deduce this equation can be substituted here, and what we will get is omega being plugged in place of 2 pi upon t. So V is equal to omega times R, because 2 pi upon T we have already derived is angular